because I was. I remember showing Victor how to use that. He's like, "Wow, look at you with your AMS volunteer."
Okay, we're gonna go ahead and get started. So before we hand it over to our general meeting, just a few announcements. First and foremost, this is our last general meeting of the semester. So before we begin, I just want to thank all of you for coming out, being consistent participants in our AMS chapter this year. Like I always say, and I will always say, it takes all of you to make this chapter successful, not just what goes on behind the scenes. So thank you for participating this year. The whole e-board thanks you. And I know your participation will be helpful next year as well. We had our AMS elections. Many of you were there. I think all of you in the room might have been there. Our president-elect of AMS is Landon. Our vice president-elect of AMS is Joey, who is here. Joey.
As always.
The vice president of external affairs is Lexi. The treasurer is Paul, who's not here this evening. The public relations chair is Olive. And the coordinator is Lindsay, who is also not here tonight. So that'll be our new e-board. I know Katie and I, who are outgoing e-board members, who have been here for decades, it feels like, definitely feel like this is a good e-board to take over what we've built over the past 3 years. I don't want to get up on a soapbox, but Katie and I saw this chapter in a time when we could barely get as many people who are in the room now, probably less than who's in the room now. So we definitely are thankful for all of you for being participants and the e-boards we've had over the last 3 years for helping cultivate what we have organizationally today. The next announcement I have is we have to hand over. I'm currently the interim director of NIU Weather Center. We're going to continue that under the umbrella of AMS. Our last meeting for that, Brandon Ward's going to make the announcement about that. Do it real quick.
Okay, so next Monday, last weather center meeting of the semester. Show up, please.
Yeah, please be there. Yeah, severe weather forecast. Please be there. We've been doing some informational presentations over the last couple of weeks. They've gotten really good critiques as far as I'm concerned. So if you're interested in learning a little bit about forecasting as well, please be there. Learn from your peers, from the upperclassmen. It'll help you tremendously in the long run. Plus, we're graduating, so exactly. You know what? Do you want to learn from us? Now's your chance. Brandon and I will still be here, but we don't want you to bother. No, I'm kidding. You can bother us all you want. With Weather Center, I'm currently the interim director. Landon's currently the interim deputy director. And so we've got to hand that over. We're going to keep it under the umbrella of AMS. So we're going to create a new role that is an ex officio, which means by position, and non-voting member of the NIU AMS e-board for the director of NIU Weather Center. And that person's going to be responsible for appointing all of the co-positions that come with that as well. And our new director of NIU Weather Center, who was just appointed, is Dan. And just like our AMS e-board, I have full faith that Danny is going to lead the Weather Center to bigger and much better things as well. So talk to Danny if you have ideas. And I'm sure you're on Discord all over the place. So you can find Danny and talk to him in person as well. So thank you, Danny. You're going to do a great job. You have anything you want to say? Speech?
No speech.
No speech.
I guess actually one thing, prior to the semester starting next semester, I'll send out a when to meet and we'll figure out the best time for meetings. Other than that, nothing right now.
So Weather Center is going to be in good hands. We're super excited for that. I'm super excited to see where Danny can take it and whoever he appoints to assist him in that operation as well. We had a fundraiser.
We did. We had a fundraiser yesterday. We did the Pi Professor fundraiser. I want to thank everybody who came out for that. Enjoyed putting some whipped cream in our professors' faces.
The photos are hysterical.
It was such a good time. I want to thank everybody because we were able to raise $206 for our chapter yesterday. So that all will eventually go back into the chapter and stuff we need to buy. So, and I would love to thank everybody who came out, and I did thank our professors for coming out and, sacrificing their dignity for 2 hours.
And their water bill
Yeah.
from the showers. They had.
Hamilton reported 3 showers.
Yep.
With all the whip.
Kate also reported 3 showers.
Okay, yeah.
Yeah.
So, and the smell is still on my nose today.
Yeah, we got Kate.
Yeah.
But yeah, so Pi Professor was a success. We'll see if Landon and the new e-board want to continue that into the next year as well, but. Anything else from you, Lexi?
I will be handing over treasurer to Paul, so if you have any ideas for fundraisers, talk to Paul. But I will be taking over as vice president of external affairs, so if you have any ideas for AMS on Wheels events, you can reach out to me, so.
Thank you. So the last thing, more on a little bit of a personal note, I want to thank the chapter and everybody who's been on all my e-boards, especially this e-board in particular, for the past 3 years. We've really made great strides in AMS, and I know Katie, come up here. Katie and I are super thankful for everybody and your support and your trust in us over the last 3 years. Combined, we have.
Imagine, that would have been crazy.
Combined, we have 6 total years on the 6 cumulative years on the executive board, so too long. And I know you guys are sick of us, but definitely thank you guys so very much. And we're excited to hand it over to Landon. Landon's going to do great things for the chapter. So without further ado, Landon's going to hand us over to our speaker for the last general meeting. The president-elect, everybody.
Thanks for coming out, everyone. Today we have Kyle Gillett. How many of you know what Sounder Pi is? Okay, a lot of you guys. I know Kyle likes that. Kyle is a Python whiz. He is currently at the University of North Dakota. And, you've got people there like Dr. Aaron Kennedy, just amazing people. So one of the things we're going to try to do with Dr. Kennedy is get Oscar set up here at NIU so we can get some photos of hydrometeors and snowflakes and all that fun stuff. So we'll try to get that going. But Kyle today is going to talk to you guys about coding and its applications in meteorology, which is really, really useful. It's nothing to be afraid of, even if you don't know anything about it at the moment. It takes some time to learn and get used to, but that's all part of it. And you can do so many amazing things with it. And it's all worth it in the end, with all the time that you put in. So with that, Kyle, I'll hand it off to you, and you can introduce yourself a little better than I did. And yeah.
Well, thank you very much, Landon. So before I get started, my plan was about 30 minutes or so, just kind of rambling on about coding and meteorology. Apparently, I have 2 different versions of this presentation somewhere in my OneDrive black hole on my computer. When I just got home from work and logged in onto to my laptop here, half of the presentation that I've worked on today is gone. Most of it I'll be able to just ramble about. There might not be any visual representation, so just bear with me on that. I might jump around between a few things, but yeah, let me start sharing here. Okay, so you guys should be able to see that now, I think, right? So yeah, programming and meteorology. Thanks, Elena, for the intro. Yeah, the whole Python whiz thing, I think, and Landon, I think you might agree with this a little bit on yourself, because I know you do a lot of this stuff, right? Less of it's whiz maybe, and more of it's we don't have a life and we just kind of sit here at this computer, right? And we're just kind of, we get an idea in our heads and we just kind of run after it until we get what we're looking for. And my goal through this is to kind of instill in you that this is not as scary as you might think it is. And through all this, I'll show you that I was in that exact same boat 100% throughout a majority of my undergrad. So yeah, this is programming and meteorology. A little bit about myself before we get too crazy here. So my current situation, I'm a master's student of atmospheric science and a graduate teaching assistant at the University of North Dakota. The research that I do is particularly related to idealized simulations of severe convective storm interactions. So if you're familiar with Cameron Nixon's storm interaction, the Nudger merger work, my current work is building off of his most recent observations study in a modeling sense. So I'm basically just using CM1 to initiate tornado genesis through mergers. And I'm also working on a summer project that's kind of attempting to identify pre-landfall signals that certain tropical cyclones might have as to whether or not they are going to be good TC tornado outbreak producers, because some are, some aren't. A lot of that might have to do with things happening on land. Is there anything about the cyclone before landfall that might give some indications that there might be a heightened chance for TC tornado activity? And I'm also the lead developer right now of the UND Outside Map Wall project. So we have this little room in our atmospheric science building, and we're kind of in the process of renovating that. And part of that is building a map wall. So it's essentially going through every single type of meteorological data you could imagine, making plots for them, and then making them real time that update on the map wall. The idea is to have this as a physical map wall, and then also electronically as a website as well. So that's going to be a lot of my summer there. Outside of academic stuff, I'm a storm chaser, aurora hunter, photographer. I'm a developer of the Chase Archive project. So that's kind of a new thing here in 2025. I'm a host of the Shoe Review show on the Chaser Chat, and I'm also one of the coaches for the new stormchasercoaching.com thing. So a lot of little things sprinkled all over the place, but kind of the big one that we really want to talk about today is going to be SounderPie, and then the other kind of programming work that I do, and kind of telling the story about someone like myself who hated anything to do with a computer when I was younger, and then I have kind of grown to be this now. I've contributed to MetPy, and I am the developer of SounderPie and several other tools, and that's kind of led to all the things that I do now. So from that, we'll go ahead and dive into kind of some background on my programming work so far. So SounderPie is the biggest one. It's essentially a tool that both retrieves data and plots data for sounding analysis, and that's getting data from observations, from models, from aircraft observations, reanalysis products like from Air 5 or the NCEP reanalysis or the RAP. Right now, the current state of SounderPie, I guess, if I had to kind of gauge where I'm at. I'm pretty happy with it right now, because in the early stages, it was a lot of, okay, here's a feature I want to add. I need to work on it some more. And right now it's pretty stable, but I'm continuously getting more and more ideas about things I want to do, or more requests from folks in the community. So eventually things might become a little bit more unstable as I start to add some things this summer. But yeah, so that this has done a lot for me. And as I'll talk about here in a little bit more, this was a passion project initially. It was kind of like the first thing that I ever did in Python on my own, like not in a class or anything, just out of pure curiosity, is I went through a MetPy Mondays YouTube video tutorial about making soundings. And I was like, this is pretty cool. And then from there, things kind of just slowly built up. And then I thought, okay, maybe some of the code that I have here, I should put it on GitHub. Some other people might find it useful, because I was chatting with a few other folks who wanted to do a similar thing that I was doing, and then it just kind of exploded into what SounderPie is now. And so this is kind of my baby, right? And this has given me an unbelievable number of opportunities so far, and I'm going to try to use this throughout this talk to kind of explain why, even if you aren't into coding right now, maybe you hate it, maybe you just haven't had the motivation to really get into it, why it's important and why you should consider doing so. Something else I never thought would be a thing, but I've contributed to MetPy. So if you go to their like tutorials on making plots and stuff like that, the advanced sounding with complex layout example, I wrote that and contributed that to MetPy. There's a lot of SounderPie-esque things that are kind of buried in there. And then I'm also working on some decape desyn stuff for MetPy as well. If I ever get around to actually finishing that, we'll see. But yeah, MetPy is something that was taught to us in our meteorology undergrad programming classes. I'd never expected to actually contribute something to that. So that's pretty neat. And then most recently, some of the development work I've done has been with the Chase Archive project. And so Jim Tang has been the absolute star on this. He's done unbelievable work, and I've just done a few things kind of sprinkled here and there, but that's kind of been the most recent project that I've really been involved in, and that's been a great time so far. I mean, working on this with Landon and Cameron and Jim and Marcus and so many other people, it has been kind of an interesting thing. It started with this little idea, and it's since grown into something that I think will have a lot more prominence here over the next couple of years as we continue to develop the tools that we're thinking about here over the next few months that we want to implement, and what that might mean for chasing in the future. So I want to go through my journey into programming. I think this is one of the more important parts of this because I think it might be relatable for some folks. So I'm going to go through some high school stuff, some undergrad, and then where I am right now in graduate school. So in high school, the only really exposure I ever had to anything computer related was this one computer science class. And the extent of what we did as far as programming is concerned was maybe working in an Excel spreadsheet. And I hated it. I was never into computers as a kid. I didn't grow up around a ton of technology. Even though my dad was actually he worked in IT, he didn't really bring any of that stuff home. That was his job, and at home we had home stuff, and there was never really anything that I got into. But I hated it in high school. I did poorly, and then when I learned that, not only am I gonna have to deal with the math going into meteorology, well, I'm gonna have to deal with computers. I thought that was horrible, and I was not looking forward to it. By the time I got to undergrad, we had this required computer science class. It wasn't even Python. It was in Java. Never have I ever once thought about using Java for anything since. It was dumb. I don't remember anything from that class. Hated it. Absolutely did poorly. I barely made it out of that class alive. Actually, since then, I think they've dropped that as a requirement for the meteorology major at Central Michigan University, where I got my undergrad. But it was so dumb, and I hated it, right? And so this was one of those classes I needed to continue the meteorology degree, and so this is when I start to think like, I really got to fix my attitude about this. And then there was a meteorology programming class, which I warmed up to a little bit. We did stuff like we used the Gibson Ridge products, we used IDV, and then we started to get a little bit into like Linux and then some Python stuff. So it was kind of just meteorology, essentially data analysis in general with a little bit of programming stuff. I still wasn't a big fan of the programming stuff because my brain didn't work that way, right? And I'm sure that there's a few of you out there that know what that is like, right? You just can't understand why we're coding. How do I tell the computer what to do? All these types of things. I didn't work that way when I first kind of got into this. But I did better in that class. And so that was a little bit of a motivation boost. And then this is kind of the dumbest way that this could evolve. I got to the point where, and I can't remember who it is for the life of me now, but somebody was posting maps from grads. It's something that used to be before Python really took off in meteorology. You could make map products with grads. And I saw someone making these maps on social media. And like we all do, when we see something that we've never seen before, we're like, oh my gosh, what website is that from, right? Where'd you get those graphics? And in this case, this person was making those maps with grads. And so I started to think like, man, it would be really cool to make my own maps and charts of meteorological data, whether or not it's like for an operational thing or just to do it because it would be cool. I just wanted to do it. So I started like poking around and things. And after a thermodynamics class, I went up to John Allen. If you're familiar with any of the Allen Nixon papers, or if you're involved at all with Ice Chip, John Allen is part of this. He was my thermodynamics professor. I went up to him and I was like, "Do you have any resources for grads or any suggestions that I should do, like getting into grads? Because I'm kind of interested in learning it and maybe using it." And he's from Australia, so in this very thick Australian accent, and I can't replicate it, but it's ingrained in my mind forever. He goes, "Forget grads and learn Python." So I thought, okay. And so I went home, and that's when that night I sat down and watched that MetPy Monday video, and that's when I kind of figured out making that first sounding. And the first version of this presentation that I had before it blew up and went crazy, I did have that in here, and it is sad. It is the saddest looking thing. But it was that one thing, it was making that plot, seeing the code finish, that kind of sparked my continued interest in this, that eventually just grew and grew and grew. So then the next year I became the webmaster for our AMS chapter. So now I could play around with website development stuff. And from there, I started getting into more of that mindset of working with computers to create something, right? Simplest starting block, right? Making the computer create something for you. And so then I started to build my own figures for class projects and things. SounderPie eventually was in its early stages. I made the Michigan Tornado Sounding Archive for our AMS chapter. Steve Pie, which Landon, if you want to collab on that at some point, I have those files just like sitting on my desktop. I have not touched them in months, but I need to finish that at some point. And then also attempting to write code for pretty much every single plot I could imagine, just out of pure curiosity, I guess, and the thought that wow, I could make that, right. You can go to Pivotal Weather and arguably those are kind of the best graphics that you can find that are easy to get to on the internet as far as like operational forecasting goes. They're clean, they're simple, right, and they're effective. My thought process was I want to just be able to make that, right, and the more and more I go through this, those graphics really are not that hard to make. It's really not that bad. And so when I started to realize those things, I was like, oh, I'm going to make this. I'm going to make this. I'm going to make this. So for like 6 months of time, and I'll have some examples of this in a minute, I would just say, okay, I'm going to make an SPC map. All right, I'm going to make the climate prediction center map. Okay, I'm going to look at radar data, or this time I'm going to look at snowfall analysis, something dumb, right? I just pick something and to try to figure it out. And eventually, all of this experience, I think, was something that really helped me get into the grad school. Because going into grad school, right, you're not just looking at, okay, how did you do in classes? What's their interest? It's also, what is a student capable of, I think, and looking at something like computer concepts, programming, right? Those are very important in graduate level research, right? Basically, what graduate level research is you are trying to prove something about the atmosphere in a sense. And to do that, you have to make the computer do that stuff for you, right? So it's just a lot of coding and programming. And I hope that doesn't scare you away, right? But that's something that a lot of graduate school positions for research are going to be looking for. And so as soon as I got into grad school, I went in as a TA. So I TA'd numerical methods in meteorology, which is modeling, and then computer concepts, which is teaching essentially the Python intro to Python for meteorology class here, and then synoptic meteorology, which at UND is also very Python heavy. So that's kind of my journey through all this, right? And now I've suddenly become the code help person. So my office has kind of become a highway with students coming in and out with questions. I'm like, I don't even know what you're doing right now, but I'll see if I can figure it out. But the funny thing is, why I put this in here is because never in my time in my undergrad or high school or anything like that did I ever imagine being at this point. So what kind of happened here? Number one is my mentality as a student. When I was first in my freshman and sophomore years of undergrad, I did not know how to be a college student. I was not a good college student. I don't think I was an idiot. I think I was just lazy and I didn't put in the right amount of effort. And so there was just this growing period where I started to realize that I needed to fix things and do better. And part of that is the second point here is going through the work of a meteorology degree. That is hard stuff, right? Think about the math. Think about the not necessarily just how difficult the classwork is, but the amount of classwork that you have to do. And not even just the meteorology, right? You're talking about the core math, you're talking about the programming classes, you're talking about the meteorology classes. And then a lot of times there's physics baked in there and maybe chemistry and all these other things. You got to own that, man. You got to walk in there and say, I'm doing this. And when I walk out, I'm going to have a meteorology degree. In my personal life, outside of the world of weather, I don't know anybody else interested in meteorology whatsoever. So for me, that is a kind of thing like, yeah, for all those people that I know, right, outside of the weather community, I am that person to them. I'm going to go in there and I'm going to own it. Okay. I'm going to go through all the work. I'm going to come out with that piece of paper, most expensive and hardest piece of paper that you can imagine, hardest to get piece of paper that you can imagine, but you go in there and own it. And so that was kind of the mentality that changed for me as far as a student. And then from that blossomed the next couple here. So in kind of changing my mentality, I also realized that I was thinking about grad school. and I was always told by guest speakers at my AMS meetings that programming is important when you're going through the process of trying to get into jobs and things like that. So I started to think, okay, maybe this is something I should really look into and try to get better at. And the amount of opportunities that arose from, being someone who could program, it really helped excel those opportunities for me. And then was also the thought of being able to provide something to the community. And that was kind of what drove SounderPie to be what it is. It instead of just having like all these files stored away in my computer and I'm just like, oh my gosh, look at this, look at that, right? Now it was thinking, okay, could the community use this? And then once I kind of realized that that was the case, like there was a quote unquote a market for this, right? That was really a motivator too, because now it shows I'm not just doing this for me, right? I'm able to do it for other people and providing something useful to the community. So I want to give a kind of update on where things are at now with the current state of things after all of this has kind of blown over, right? Now SounderPie, it currently has a paper in review with the Journal of Open Source Software. I never imagined I'd be writing a paper on code and then submitting that to a journal for review. If you've ever heard of the book Synoptic Analysis of Forecasting, an Introductory Toolkit, the second edition of that, which should come out sometime this year, will be teaching soundings with SounderPie soundings. SounderPie has been used in a ton of conference posters, presentations. It's been published in several peer-reviewed journals and things from the US and foreign countries, which I never imagined would be a thing. And it's even used operationally by the National Weather Service, several National Weather Service offices, and it's used and taught all over the place at different universities. And so, again, this is all taken place over about 2.5 years of time. I started doing this kind of thinking about coding and actually going through the process of making my own plots in 2022. And it was about March of 2022. Since then, that all of this stuff that I've described has happened. And what I want that to show is as long as you're motivated to do it, and you can sit down and say, okay, I want to try to figure this out. I want to try to figure this out. I want to try to figure this out, whatever it is, you're going to get to a point where you are, even if you don't feel like it, you will be growing and excelling. And eventually you're going to realize just how far you've actually gotten. And that's a huge deal. Now, as far as my presentation is concerned, this is where it got cooked by my OneDrive. So what I'm going to do now for the moment is I'm going to kind of convert your attention to, can you guys see the screen that I just popped up there?
Yep.
Okay, so it looks like a plot here.
Yes.
Okay. Will it play is the next question. Let me try something. So what I'm going to do now, and this is kind of something that I had kind of planned here, was to show you some of the plots that I've made. And hopefully you could just look at it and go, wow, that is neat. I want to do that. So it looks like it's going to play now. So this is some of my research stuff. What you're going to see here, this is a CM1 simulation of a supercell, a barely tornadic supercell, nice hook echo, and then eventually I initiate a second storm near the RFD, and then it's going to merge with the parent, and I'm currently working on some microphysics garbage that's happening with my CM1 to make this look nicer. But what actually eventually happens here is that compared to a control run without the interaction, this supercell lives for about 3 hours longer. In the control run, it just died after a few hours. But then with this run, when I actually initiate the interaction, it lives much longer, and it does produce a pretty strong tornado right there. So again, a few issues I have to mess with here to kind of fix to make sure that I'm doing this all the way correct. But this is an example of a figure that has been made from my research, and this is all Python, and there's really nothing fancy about this at all. You just have two plan view plots. It's not even an actual map, right? Because CM1 is on X and Y grids, not lat long or anything like that. So it's just two X and Y plots here, and then you have two charts down at the bottom. And there's nothing fancy about this. This is just multiple images that are put together into a GIF, right? The actual amount of code, the lines of code to make this are probably only about 200 or 300. That might sound like a lot, but that's really not that much. It's a pretty simple code. And this is kind of one of those fancy things that when I first started getting into coding, I was like, oh, man, I want to be able to make something like this. This is really cool. And so part of the presentation that got deleted that I wanted to share is understanding kind of like a motivation for, um, actually, here, let's do this. Okay. So something I wanted to kind of share about um, why you should consider programming in general is because, oh, man, and I had this great line written down too. So think of it as you are telling a story through some kind of data, Taylor's version. Okay. So what you're doing here is you are taking some kind of data like the CM1 output, right? And then what it looks like before you do anything to it, it's just numbers, right? Numbers that are all like arranged in some order and it's gross. But then you can take whatever you think is best to convey whatever story you're trying to tell. You can make that in programming. And I had some examples pulled up here. Unfortunately, they have completely disappeared. But I do have, let me see if I can share again here. I have my like little portfolio thing on my website that I will share. And we can walk through that because there's some examples on here. Okay, so if you can see this screen, an example of this that I wanted to show is, let's see where it's at here. It's in here somewhere. Oh, so let's just start with a sounding here, right? So, something that you see all the time, right, is if you go to like Pivotal Weather or something like that, right, you're going to find a sounding, and that sounding is going to have just some arbitrary lat long coordinates, right? And what does that actually mean? But can you tell exactly where something is with the lat long coordinates? I don't think you can. But you need some kind of map, essentially, to show you where things are, right? How do you actually know? Because let me put in the sense of context, right? Um, you can't just look at a sounding and go, "Oh yeah, that sounding looks fantastic," right? You want to know where the sounding is. It in front of the convection that's moving through? Is it behind the convection? Right? All these things matter for whether or not that sounding should actually be used in maybe a forecast sense. So here's an example. This is the one that I was looking for. This is Pilger. This is the Pilger sounding. Pretty crazy sounding, right? But if you just give me the lat long coordinates, I have no friggin' idea what that means, right? So the Taylor's version reference that I made there is taking this data and making it your own, right? Put the map on here, right? Where is it at in context with the map? Okay. Um, Making sure that when I give a lat long coordinate, right, it can figure out where that actually is. Well, I know where Omaha, Nebraska is, right? I might not be able to picture in my mind 41.32 minus 96.37 like you might get from Pivotal Weather or COD or something, right? It's these little details. And this is kind of what I mean by Taylor's version, right? It's you taking something, sure, it might already exist, right? You can get soundings everywhere, but making them more intuitive for yourself, right? Displaying things the way that you want to display them. For example, some other things on here that are not something that you find in other like sounding sources like Pivotal Weather or COD if you're just looking at models, or maybe from the SPC even too. Where actually is the 3 Cape marker at, right? And we're in the 6 Cape marker. Where is the freezing line and the wet bulb freezing location at, right? What about these plots, right? Storm relative wind in the lowest 3 kilometers, or the streamwiseness of the vorticity in the lowest 3 kilometers, right? These tell different stories, things you're not going to find elsewhere. And so that's kind of the motivation behind Sounder Pi. Is like there's other things that I want to look at that I can't find on most sources, right? And there's another example in here, right? So this is a dropsonde. This is the same thing. We never really see good dropsondes that have the map also on the dropsonde, so we can easily see where this dropsonde came from. And this is a plot that needs some help right now. I'm kind of working on hopefully adding dropsonde stuff into SounderPi soon. But this is an example. This is a satellite image with lightning flashes on it and the location of the actual dropsonde in it. And that's also located with this NHC track right here, right? So it's these little details, right? That this is you telling the story how you want to. Sure, you can go to Tropical Tidbits and get a dropsonde and be just fine, right? But it's you doing it your way. this is just purely to do it, right? This is, you have roads on here, you've got towns and all that kind of stuff, and it's little attention to detail, but it's you telling it in your own way. And I think that's one of the big things about coding, right? And it's kind of like art in a sense, where you might have some easier way to do things, right? Or something might already exist, but you add your own little touch to it is at least what has helped to motivate me. Like paying close attention to how I, do the mapping, right? This is an example here. So this is a kind of storm following sounding from the Tuscaloosa 2011 tornado. And so you can see there's tornado tracks and storm reports plotted on this, as well as radar down here in the map. And then all the little, sounding things on here. So what I'm trying to get at here is that even though things might already exist, or it might be difficult to kind of figure out the best way to make something, or whatever it is that might be currently keeping your motivation at bay, if you will, there's ways to make it your own and get excited about it. And as far as coding is concerned, like the actual process of going through making something, when I was first getting into this, the thing that really got me was, how do I actually, number one, arrange the letters and numbers in the right order to make the computer do something, right? If you're going to learn Spanish, right, there's different forms of words, okay? And there's a pattern that you can follow, right? So Spanish, relative to maybe a programming language, has a much easier to follow, I guess, pattern, for lack of a better way to put it. But when you look at something like Python, right? Python is written by programmers. Programmers in nature are generally lazy people. So instead of, for example, the numpy square root function, instead of writing out square root, it's SQRT. Nothing in English tells you that that is how you should, write square root, if this makes sense. So what I mean by that is the syntax, right? The order of letters and numbers and the characters. When do you use plus signs? When do you need to use two equal signs? That kind of thing. That is not what you should focus on when you're first trying to get into coding, right? Because that's what documentation is for. It teaches you the right order of characters to make the computer do what you're trying to get it to do. However, that is a little, in a sense, tied to this next part, but it's less important. So the next part and the most important part is logic, right? So coding is simply a logical arrangement of letters and numbers to make a computer do some task, right? And so the arrangement of the letters and numbers, who knows, right? It's different between every single coding language. It's different between Java, Python, C++, whatever, okay? That doesn't matter. That's easy to look up and figure out, right? But it's the logic. How do I solve this problem? And this could be something silly like, maybe I want to make a plot that has wind barbs on it, but when I plot it, right, there's way too many wind barbs on it. What is a logical way that I can go about removing some of those wind barbs to make the plot cleaner, right? It's that logic that really sets apart good programming from bad programming. And so if you're stuck and you're like, I don't know what to do, I'm not sure where to go with this, I don't know, as far as coding is concerned, forget syntax. Syntax will come with time. Focus on building logic. And the best way to do that is just open up a Jupyter notebook and just try to make something, because you're going to break that code. It's not going to work. You're going to have to close the laptop and come back later. That's part of it's part of the game, if you will, right? The amount of times I've just shut down my computer and walked away and then come back the next day and been like, I'm an idiot. It was right there the whole time, right? That's normal. That happens. Coding's frustrating, right? Imagine that you are trying to paint a picture literally with some figure or something, but you can't actually ever see the picture, right? You're just arranging what the picture is going to look like with letters and numbers. It's not easy to figure out how to do that, but with time and practice, it's something that will eventually kind of grow on you. I think, and that's at least what happened to me. So my my advice is to pick something that you think you want to make and then research it. watch MetPy videos on it, right? Something like maybe a surface map or maybe some kind of GFS plot or something like that, right? And then get it into your code and just step by step, just practice it. Just try it, right? And it's okay to break code. Don't be afraid to break code. One of the things that I see all the time with my students in the computer concepts class right now is that they are not confident in themselves, right? And they think that if they're writing this block of code and they get to a point where it's maybe they're lost on what the next step needs to be, or the one part they're working on isn't working, they feel afraid to run it because they know it's going to be wrong or something like that. But it's okay to run it, right? It's okay to break the code because it tells you something about what you might need to fix or whatever. So be confident in yourself. Okay. It's literally just you and the computer, right? And at the end of the day, uh, more likely than not, what you are trying to do, someone else has already done, got stuck on, and asked for help on Stack Overflow. So, like the issues you might have, somebody else has probably already gone through it, or a similar logical issue. So, all in all, I guess I'll kind of wrap up a little bit with this. The easiest thing you can do for yourself, even if you're in a class, right? I could not learn coding in a class. Couldn't do it. I had to do it on my own. Even if you can't, do it in a class, or you're struggling to figure it out for some project you're working on or research or whatever, find that one piece that's almost a passion for you, something that you're like, oh man, I'd really like to make that. And then just try it, break it, try it again, do some research over and over and over again. And eventually you'll go from making that one crappy MetPy sounding plot to, something much better, like, growing into something like SounderPy eventually, right? So it's just taking the time to actually work your way through a problem and putting in that effort and being confident in yourself. It's one of those things that uh, I don't know how else to describe it other than it sucks initially, but then with time it'll get better. So I apologize with the presentation issues. I had so much other stuff in here that I know I forgot to say, and it was much more organized. But I don't know what happened. I guess OneDrive hates me, but that's part of the game, right? Write a script and then you didn't save it, and then it's all gone. That would be much worse, I guess. So with that, I thank you guys for your time, and I'll take any questions if you have them.
Thank you, Kyle. Do we have any questions in person? Brandon.
Okay, so I do a lot of Python coding. Landon and I also, we do a lot of working together with our stuff, but in particular, I do a lot of machine learning stuff, and I was wondering if you've done any machine learning, or if you've had to venture into that realm yet, or if you plan to, and what you have or plan to do.
Yeah, I do plan to actually. I haven't yet. I just haven't had the time to kind of sit down and focus on actually learning it yet. But I've had an idea for a while. And this is something that's kind of going to be related eventually to like the Chase archive and stuff, but related to soundings, right? I just want to be able to take a forecast sounding and compare it to what we have from the past, and see which analogs are closest. We have something like the SARS analogs now, but that's kind of outdated. At the time, that was the best we could do, but now with machine learning, we can do better. And then from that, especially with something like where Chase Archive is right now, right? We have, and essentially what this is, a high level overview, right? We bring in chaser reports, and they're actual chase reports, not storm reports, a little different. And so there's media associated with them, and that media represents whatever the storm looked like, or how a chase evolved, or something like that. And then we have soundings for all those reports. Can we take the visual representation of this storm? Can we relate that to the profile and kind of do some machine work there, right? And then can we give it a forecast, and can it spit out uh, a some kind of probabilistic guidance as to what a storm evolution might look like, what it look like visually, maybe something like that. So I have some sounding stuff I want to do eventually. Will I get to that? I don't know, but that's definitely in the plan. Yeah.
That's really interesting. Thank you.
Yeah. Thank you.
Other questions in person? Danny?
You mentioned a few times MetPy. What other resources have you used in your journey along the way?
Yeah, so MetPy is a big one. MetPy has a lot of tutorial stuff, and there's a lot of they do a lot of YouTube video stuff. The MetPy Monday, where some guy just sits there and he like walks through some problem, and you can like work on it together and whatnot. Unidata also has a lot of its own resources, and MetPy is a part of Unidata, the whole thing. But there's a separate gosh, I forget which part of Unidata it's under, but if you just search up like Unidata Python resources, there's this whole thing that talks about how to set up Python on your computer, how to use notebooks, and then some really basic Python stuff, and then Python applications in meteorology. So as far as resources for learning Python, I would say that's almost it for what I have done as far as resources. Everything else has been I know I want to make this SPC map. How do where do I get the data from? Okay, so now I'm learning how to pull in data because I had to look that up in the moment. Okay, now I need to make a map. So how do I learn how to make a map? Well, I'm just going to go research it. So a lot of this stuff comes from in the moment. I have a problem. I need to fix it kind of thing. And so it's just a lot of researching and browsing GitHub and browsing stuff like Stack Overflow and all those forums and stuff. But Unidata and MetPy are excellent resources. They have all kinds of information, super simple stuff, and then even getting into some of the more advanced stuff too.
Sean?
What is your opinion on using ChatGPT to code?
Yeah, no, that's a good one. That's a good one. So I personally don't use it. I've only used ChatGPT once, and it was to make some color tables for me. That blew my mind because it worked away instead of making it manually by typing in all the RGB values for something I was trying to do. And I'm also colorblind, so I can't do it by hand. I have to make sure, it's right. And so someone suggested using that. So that's the only time I've ever actually used ChatGPT to code. I whatever works for you is how I'll put that. For me, I take pride in being able to come up with it on my own, right? Like I said before, part of it is syntax, part of it is logic. And I guess it might depend on the type of question that you ask, right? But if something like Chat GPT is figuring out the logic for you, there's no need for you to do this, right? The logic, the human logic of saying, okay, I need the computer to do this for me, and creating that code to do that. That is what programming is, right? So personally, I don't use it. I try my best for the classes that I teach that use programming to keep students away from using it, right? Because we want to actually teach programming. Obviously, there's probably going to come a point where there's something that you might be trying to do, and it's just impossible, right? And there's no prior effort that's been done or anything like that. So what do you do? Well, maybe AI knows what the answer is. So again, kind of a roundabout way to answer that. I personally don't use it, but whatever you need to do, you need to do.
I definitely feel like there's a limitation to it. Obviously, like the more sophisticated your code gets, obviously using ChatGPT is very, very difficult to really work around it. But I found it most useful in, as you said, syntax, context, stuff like that. So I just wanted to know your.
Yeah.
I think
No, that's a good point. So what I'll say is, right, and when I bring up the whole syntax thing, syntax doesn't matter because I forget the name of functions and things all the time. I'm like, oh frick, how do I do this? And it's only after I use it 100 times do I actually remember what it is. So something like that, that's totally that makes a lot of sense. But yeah, the one thing I will bring up about AI, and I've seen a lot of discourse on this, especially if you are going into research, atmospheric research, right? The big thing in research is we want to be ethical researchers, right? The problem with using something like AI to write code for you is that if you don't like very carefully comb through what that code does that the AI gives you, if you're not very careful about that, it might run code for you that works, but it might not actually be the analysis of the data that you need it to be. So your results could be skewed or not what you expect them to be. So what you said there about, how advanced you are and what you're trying to accomplish, when you start getting into research stuff, I think that's 100% the time to kind of try to stay away from it, especially for more complex things, because I don't know, just as an example, let's say like I need to plot a graph of some sort of statistics for um I don't know, tornado deaths and storm reports or something like that, right? And then you tell the AI to figure this out for me, help me make this graph, but it misinterprets what you asked, and it could flip your results. It could do the wrong statistics or something like that, and you can see, okay, there seems to be more tornado deaths when we have less storm reports or something dumb, right? So that could flip what your research results are, and of course, we don't want that.
Yeah. What were you gonna say, Brandon?
Oh, I was gonna say, I feel like ChatGPT, if you're gonna use it, you have to understand what you're looking at, because a lot of times people will just take it and copy and paste, and then they get, like you just said, some garbage result. So at the very least, if you're gonna use it, just know, and I've done it before. I've fallen into the stupid black hole and I got chewed out by a professor for it for some undergrad research. But if you don't know what your code is doing when it spits it out at you, it's dangerous. It's like one of the most dangerous things you can do, because it just could be complete garbage.
Yeah, and I actually just talked to a professor here at UND about this not too long ago, because just imagine that you do some research and that involves some code that you used AI for, or even just your own code. You could write it incorrectly yourself. That's 100% possible, right? But just say you have incorrect code that gives you incorrect results, that goes into a paper that's published. Maybe the reviewers don't catch it, and then it's cited by X number of papers later on in all their work. If you go back through one day and you're like, oh shit, I really did not do this right. Well, not only is your research messed up, but then all of the research that's fallen out of that is also messed up. So and of course, AI could do it wrong. You could also do it wrong, right? So I think the moral of the story is just be very careful. But yeah, AI is one of those things we're never going to be able to escape. So eventually, it just might come packaged in Python when you install it on your computer, right? Who knows? And a lot of tools these days, like I use PyCharm on my computer, and PyCharm has AI stuff built into it. So some of it's like impossible to get away from. But yeah, for me, I think it's personal preference as long as you're just careful about it.
Copilot.
Yeah. Yep.
Yeah, I know Google Colab already has AI built into it too.
Google,
So
Google Colab's built-in AI is interesting. It autocompletes the things I'm about to write.
Yeah.
Before I even start typing them, I put D in it and it goes DF equals that. I'm like, what? It's like a mind reader.
Yeah, I actually forgot about Colab. Me and a professor use Colab when we write the labs for the computer concepts class that we have. And so we spend most of our time in Markdown writing down the instructions for what we want the students to accomplish. And then we write the solution after that. But the AI just reads our Markdown and then almost all the time just writes the code. And it's like, but sometimes it is wrong. Even these like super simple things that we're asking it to do, like basic learning Python, it'll mess it up. But it's crazy what it can do. That's for sure.
anything else in person? Anything online from Gavin or Hayden? So Kyle, Hayden is a high school student, and he does a lot of stuff with like radar data. So Hayden, maybe you can plot some radar data.
Yeah,
Awesome.
I mean, I was just looking into like some of the stuff for Sounder Pi because I wanted to pull soundings for a significant tornado that happened in my area, and maybe I could do a little bit of analysis on it. But yeah,
Hey, that's how it starts, right? That's not an assignment, right? That there's no due date for that. That's just you being curious. That's how the bug starts.
yeah. And I've done a lot of research on it too, just trying to pull as much as what I could without like Python and stuff too. Like I already like downloaded, Nextrad files from it. I tried pulling stuff from Wyoming State and stuff, but
Mhm.
yeah, I think if I get more into coding and stuff, then I can definitely like get more and more data. Yeah,
Yeah, absolutely.
it's really cool. Like I just like now like you just talking about it and stuff, like this is like really my first time of like actually seeing like what Python can do.
Mhm.
Definitely.
Yeah, it's very powerful if you just take the time to figure it out. That's really all it takes.
I see. But yeah, that's really all I have to say. But yeah.
Yeah, thank you, Hayden.
You're welcome.
All right, well, if we have no more questions, we can thank Kyle one more time.
Thank you, Kyle.
Yeah, thank you. It was a very good talk.
Thank you. Yeah, again, sorry for the presentation meltdown there, but yeah, thanks a bunch, Landon. Thanks for having me.
That's technology for you. So
coding, right? Yep. Yeah.
All right. Well, I think we're good to go. So Kyle, you have yourself a great rest of your day.
Thanks. Take it easy, guys.
Thank
Thank
you.
you.